All right, what we want to talk about today is the idea of a derivative. Now, this is a huge idea of calculus. It's the main idea of calculus. But let's just look at how we calculate them, and then we'll sort of see what they do. So, for this first one, the derivative, we would write f and put a little marking there, a little tick mark that says the first derivative. It's equal to 12x squared plus 4x minus 8. Now, can you see what I did? Probably not. What I did was very simple. I took the exponent and I brought it down in front. And then 3 times 4 is 12. And then that exponent, I took 1 away from it, which made it a 2. Right here, I took the 2, brought it down front. 2 times 2 gives me this 4. And then x went down 1 power to x to the first. Here, now technically you have a 1. 1 drops down. 1 times 8 is 8. X goes down a power. 1 minus 1 is 0. Any number to the 0 power is always 1. So this is just a 1. So 8 times 1 just is 8. That's what we have. So if that's what we do, what is the derivative of this second one? It's very simple. Just bring that down front. 3 times negative 3 is negative 9. X. It goes down a power. So it goes from 3 to 2. On the next one, the 2 drops down in front. There's nothing there, so it's a 2. X goes from the second power to the first. Remember, this is just an x. It's to the first power. So 1 comes down. X goes to 0, and anything to the 0 is just 1. And now what about this number? Well, what you technically have is this is x to a 0, and you bring the 0 down. What's 0 times 6? 0, and it cancels everything out. So anything, any whole number, 7, 8, it's always just going to disappear. So the derivative for this guy right here is that. Down, multiply the 2, and then drop the exponent by a power. So as we said, what if I had f of x equals 20? Well, remember, that's really 20x to the 0. So 0 would go out in front. You'd have 0 times 20x would go down to the negative 1, and it's all just 0. Any whole number or integer is going to disappear. Now, the next one's a little tricky. You must rewrite this one first. We can't deal with x's in the denominator. We can't deal with it. We have to rewrite it. So I'm just going to rewrite it. It's very simple. It's 5 times x, if we bring it up, negative 3. Remember how we write things with negative exponents? X to the third down in the denominator is the same as x to the negative 3. Now I can take the derivative, and again, we put the little tick there to show the derivative. Negative 3 drops down in front, gives me negative 15x. Now remember, we drop a power. Negative 3 dropped. If it's negative 3 degrees outside and it drops a degree, it's now at negative 4. Now we could leave our answer that way, or we could rewrite it and go ahead and put x back into the denominator. This is the way I would do it. And on a test, that's probably the way, if I had multiple choice, that I probably would do it. You should know how to do that. So the derivative really is not difficult to do. But what the heck is it? Well, before we talk about that, let's talk about this. Have you ever heard anybody say, hey, man, we were talking and then we went off on a tangent? Well, what do they mean they went off on a tangent? Well, if you're having a conversation talking about a main idea, it's all right in here. And then all of a sudden, you start talking about something out here on the edge, and then it just drifts away from the conversation. It just drifts away. It's sort of on the outer edge, and then it just goes away. They went off on a tangent. Well, a tangent line is a line that touches a circle or anything in exactly just one spot. And here's what we have happen. You have lines. Let's say there's our line, a graph of something. Looks like an x cubed plus 2x or something, maybe. I don't know. So what happens is if we zero in a million billion times. Now remember, these are curved lines. They don't have a slope, do they? No, they don't have a slope. But if we zoomed in a million billion times right on that spot right there, let's say, well, if we zoomed in, it would look like a straight line, wouldn't it? And we could give the slope right at that point. We could say, hey, at that point, we zoomed in so far that the difference between here and here is maybe a billionth of a centimeter. So we could sort of calculate the slope because it would almost be straight there. Well, that's what we call the tangent line. A tangent line comes in and it touches just at that spot. Doesn't touch anywhere else except for right at that spot. And that's the tangent line that touches just in one spot on that graph. It skims it and then skims away, which is really, we're going to look for the slope there. And the tangent, the derivative. The derivative is that magical equation that tells you the slope at any particular point. So if I want to know the slope right here, I would find the derivative of that black line and then plug in whatever the x is there. Because when I take the derivative, it's going to tell me the slope anywhere on that guy, anywhere on it. So back here at the beginning, if I graph 4x to the third plus 2x squared minus 8x, if I graph that, the derivative, this equation right here, tells you the slope at any point on this guy. It tells you the slope anywhere on there. It's crazy that just doing something as simple as that gives you the exact slope at that point. So what we're going to say, instead of saying, hey, zero in right at that point and tell me the slope, like here, tell me the slope at the point 1,4, we're literally going to say, hey, it's the tangent line that touches right at that given point. So if we have this graph, which I'm telling you looks something like this, I want to go to the point 1,4, right here at the point 1,4, and I want to know the slope right there. Now, what we're going to say is, hey, I'm going to draw a line that touches just in that spot that will have that same slope. So what is the slope of the tangent line at that given point? Well, all we do is we take the derivative. The derivative is the magical equation that tells you the slope at anywhere on this line. So 3x squared plus 2, that right there is the derivative, which means that right there tells you the slope anywhere you want. Well, where did you and I want? We wanted at this point. Now notice the equation's just in x's. So all you have to do is plug in the x value and that'll tell you the slope there. So let's plug in x being 1. 3 times 1 squared plus 2. So that's 3 times 1 plus 2. 3 times 1's 3 plus 2, 5. I guarantee you the slope of this line that's touching right there, just in that one little point, this guy has a slope of 5. All you do, take the derivative and then plug the x value in and it'll tell you. If I had wanted to know it right here, let's say that's maybe like -3, the slope of that tangent line right there, I would just plug -3 into the x and I'd have it. I could do it down here, maybe when x was -5. All you do, again, the derivative is the magical equation that tells you the slope at any particular point on the original graph.